Welcome to week 10, day 45 of the fall 2024 Programming Fundamentals with C Sharp. I'm Jim Kaufman with Rankin Technical College. So this week, we're going to go over a few different things. Today, we're going to go ahead and go over Chapter 19 lectures, Introduction to Database Programming. Makes things a little much more interesting. So we'll be, at some point here soon, we'll be actually connecting to a database. It makes application development much more fun when you're actually connecting to data and pulling back data from a database. And then tomorrow, I'm going to go ahead and go through the assignments. The hands-on test there's not probably much to go over on that. I think probably most of what I'm going to actually be going through is the final project. So the final project's 1,500 points. It's going to be kind of a multi-step thing that we'll be working through the next probably 4 weeks. And so then we'll be going through that. And then I'm also going to go ahead and show you, we're going to go through some more database stuff. Today we're just going to do a lecture, but tomorrow we'll go ahead and connect to a database and go through some basic database functions as well. So, okay, let's go ahead and start the presentation here. So today we're going to go ahead and go through this chapter 19, and we're going to describe the hardware components of a typical multi-user system. Just describe how software components of a typical multi-user database application. Explain how a table is a relation database is organized. Explain how the tables in a relational database are related to each other. And we'll look at some basic SQL statements, which are select, insert, update, and delete. So here's a picture that depicts a simple client server system where you got your clients, which your clients are going to be your computer, your PC, your laptop, or any other kind of device possibly that would go through a network to access data from a database server. Okay, and here this database server, you can look at this in kind of like two different ways. One from a hardware perspective, where it's the actual physical machine itself, and then also from a software perspective, because basically a database server is software that's actually the real database server is actually a software product, and it's installed on a physical machine. Now, this physical machine, here it's stating a database server, this physical machine, the difference between maybe this one and something that would host maybe a web application would probably be created a little differently. And it's basically the components of that hardware system are going to be, it's going to be set up where it's going to be set up more for a database where, storage, you got a lot of storage. So, you're going to have a big hard drive on there or however you're actually handling your storage. But the components are going to be set up to actually, benefit from a database perspective. Now and we'll talk about this a little bit more here in the next few slides, but there's different kinds of databases. For this one, we're going to use like a Microsoft SQL server, and then there's also other ones as well, like Oracle. There's Oracle database. There's IBM, which is the DB2, and they're all different databases. Now those three, the MySQL, IBM DB2, and also the Oracle database, them are all basically licensed databases. Now, they do also offer kind of like free versions to be used, but most of the time in a real enterprise type environment, them are all going to have license agreements with the different vendors, right? So, and the vendors being, Microsoft, IBM, Oracle, that's the company names, and them are the vendors of the database servers, right? And so usually in a lot of organizations and enterprise, large organizations, you're going to have license agreements. So that's usually a paid type thing, right? You're paying for that. You're paying for support from the company. But like I said, there are some, you can use, there's scaled down versions that we can use for free and stuff like that. Mainly a lot of times when you're using those kind of databases, it's an enterprise and there's going to be paid services for using that. There's other ones as well, like MySQL is probably one of the more popular relational databases that are available basically for free. And even that one there also has even that one there also, they also have other, some companies support them. And if you want help from support for MySQL, you'll also can get support from a license agreement for support for that as well. So here's the three hardware components of a client server system. You have your clients, and that be like in this case, talking about PCs, Macintoshes, workstations. Even an iPad could be a client. Anything that's going through a network to connect to a database, could be a client, right? The server is a computer that stores the files and databases of the system and provides services to the clients. When it stores databases, it's often referred to as a database server. Like what we were just talking about, the hardware part, the hardware parts, basically your bare bones computer, and there's going to be certain components that are going to be configured to maximize for a database, performance and storage and stuff like that. Then your database itself is actually a software product that's going to be installed on that hardware database server, such as and different database servers, like we were saying, hardware software would be like Microsoft SQL or Oracle or IBM's DB2, etc. Right? The network consists of cabling. So basically, if you work at a company, you could be working at a company where you've got a closed system where you've got a bunch of different clients that through network cables connect to a database. And that could be kind of a closed system within an organization sometimes, or it can be over the internet, which would be a little different kind of a setup there. So in a simple client server system, the server is typically a high powered PC that communicates with the clients over a local area network. Okay. And where we're talking about local area network, usually that's, like I said, that's more of like a closed system. It's more of a system, that's just really available to computers in that little local area, right? As opposed to being over the internet would be, a much, that would be over the internet be a little different, right? The server can also be a mid-range system. Okay, they're just talking about different. They're talking about different kinds of hardware here. It could be. They're just giving some examples. But the important thing to know is the hardware is kind of configured to really just support databases. Sorry. A client server system can also consist of one or more PC based systems. Okay. Let's see. Individual systems and LANs can be connected and share data over large private networks, and that's considered a WAN, a wide area network. So here's just showing you an example of having a client, and then your client would make SQL queries to a database server. Database server would return the results. Okay. To manage the network, the server runs a network operating system. Okay, yeah. So for MySQL, basically, if you've got a database server, not MySQL, I'm sorry, like a Windows SQL for for that, you're basically running that on a Windows server. So that there's an operating system also running on that hardware, right? So the operating system is, there's different kinds, and for Microsoft, it's going to be a Windows, it's going to be a Windows server. To store and manage the databases of the client server system, each server requires a database management system, such as Microsoft SQL Server. The processing that's done by the database management system is typically referred to as the back-end processing, and the database server is referred to as the back end. Okay. The application software does the work that the user wants to do. This type of software can be purchased or developed. The Data Access API, the Application Programming Interface, that's what API stands for, Application Programming Interface, provides the interface between the application and the database management system. So it's just telling you that Microsoft's Data Access API is the ADO.NET, which is part of the .NET framework. The processing that's done by the client software is typically referred to as front-end processing, and the client is typically referred to as the front end. Okay, the SQL interface. The application software communicates with the database management system by sending SQL queries, which we'll learn how to do SQL queries, through the Data Access API. When the database management system receives a query, it provides a service like returning the requested data, which is called the query results, to the client. SQL, which stands for Structured Query Language, is the standard query language for working with a relational database. So there's other kinds of databases besides just relational databases. Relational databases were, been around the longest, and they're still heavily used today. But there's also other different types of databases as well. We're not really going to go into that too much. We might, I might bring that up now and then here in the next couple of weeks. But for the most part, we're just worried about relational databases. So here, this is an example of a products table, and this, from the chapter book. This is just an example of that. So here you got columns, you got rows and columns. Always think of each row is a record, right? And the columns are attributes, right? So for this record, for like this first line here, product code Android, this is a record, right? And this record is going to be composed of different properties, right? A product code, a description, a unit price, and like here's on hand quantity. So quantity. How a table is organized. A relational database uses tables to store and manipulate data. Each table consists of one or more records or rows that contain the data for a single entry. So always think of a row being a record within a table, okay? Each row contains one or more fields or columns, with each column representing a single item of data. most tables contain what's called a primary key, and that uniquely identifies each row in the table. That way you can bring back a complete record, which is a row, by using this primary key. Some database management systems let you define one or more non-primary keys. In SQL Server, these keys are called unique keys, and they're implemented using unique key constraints. A table can be defined with one or more indexes. An index provides an efficient way to access data from a table based on the values in specific columns. An index is automatically created for a table's primary and non-primary keys. So here's two related tables. And we can make this a little bit bigger here, maybe. All right. So here we got two different tables, invoices and invoice line items. So these are actually related to each other. So as you've got an invoice ID here, in your invoices table, in your invoice line items, you also have an invoice ID. So you're able to actually, based on one table, you can actually bring back data from a additional table, right? That's also related to the first table, okay? How the tables in a database are related. The tables in a relational database are related to each other through their key columns. A column that identifies a related row in another table is called a foreign key. So in this case, this is your primary invoices, is your primary table, right? This is considered your primary index, right? Your primary key is invoice ID. But here, actually, this is actually the foreign key of the second table. Invoice line items, this is considered the foreign key, okay? Usually a foreign key corresponds to the primary key in the related table, okay? And that's what we just looked at. In the SQL Server, however, a foreign key can also correspond to a unique key in a related table, okay? So it's basically saying it, in some cases, the foreign key is going to be kind of basically the same key as the primary key, but not in all cases. It can also correspond to a unique key as well. When two tables are related via a foreign key, the table with the foreign key is referred to as the foreign key table, and the table with the primary key is referred to as the primary key table. The relationships between the tables in the database correspond to relationship between entities they represent. The most common type of relationship is a one-to-many relationship. A table can also have a one-to-one relationship or a many-to-many relationship with another table. And we'll go into those. Them can, it takes a little while to understand some of that relationships. Kind of the same thing we talked about that a little bit when we did the UML stuff, right? A one-to-one relationship, and sometimes in some cases you have a one-to-many, right? So here's the Server Explorer design view window for the invoice table. It's basically showing what your keys are, the foreign keys, the triggers. Okay, in our case, we're really worried about for now, we're worried about the primary key. What's the primary key? And do we have any foreign keys also? Okay. So there's different types of data that you can store in your database. Not everything's a string, right? A lot of you probably view it, you look at it thinking of things being more of a string, but there's all kinds of other types of data types as well. Okay, and we'll go into this a lot more here coming up within the next couple weeks. But you got a bit, you got chars, you got what's called a varchar. We're not going to just run through all of these, but obviously you can store numeric values, integers, money, etc. Okay. So here it's showing that here's some tables that make up this example database from the book, and you got customers. So customers can have. So yeah, this is showing you how this can be related. Where here's a customer, you have a state, you got a state code, right? So basically your state, when you build this thing out, you get your state code from the states table to put in your state variable here, right? In your state column. And then a customer can have, one or more invoices, right? It could have multiple invoices. It can have multiple invoice line items, and it can have, and each invoice line item, multiple products, right? So here's a simplified syntax of a select statement. Now, one thing I did want to bring up, there's this idea of, it's kind of more of a general term, looking at a higher level term. So when, these SQL statements were the basic, four we're going to be looking at is a select statement, an insert statement, an update statement, and a delete statement. But there's also this concept of databases, relational database being called CRUD operations, and a CRUD operations is basically create, which would be the same as insert, right? You have read. Read is going to be the same as select, right? And then you have update, which will be update, and delete will be delete. We'll talk about that more, but it's basically just the concept of databases, relational databases having what's called CRUD type operations, and that's the create, update, delete, and create. Okay, and so here a select statement, which would be the same as a read, right? So you can select just one column from that database, or you can select multiple, or you can do commas and do multiple columns, or you can do all. Okay, and we're going to look at all these different ones, not necessarily today, but we're going to go and do some more advanced type database queries, so you'll understand that a lot better. But basically, here's the syntax. You're going to select a column, one or many columns from a table. You have to designate which table you're wanting to get the data from. Where, and the where is going to be maybe some certain conditional type thing. Is maybe it's a table of students or something, and you got ages for each student, and so you want to select from this student where the ages are greater than 18 years old. So that would be kind of a where clause, some kind of a criteria, right? And then you may want to bring back the data from that table in a certain order, right? And that's where you use an order by. So you may want to bring that order by last name, or you may want to order it by student ID, etc. Okay. And then it's showing you here also, you can do it by ascending or descending. So if you wanted to bring back, the last name, being the descending values Z down to A, or ascending A to Z, right? And it wouldn't necessarily have to be, all it's going to be numbers. Like we said, student ID, right? Numbers. It's going to be the lowest number would be ascending, would be your first one. If it's descending, it'd be the largest number, right? So here's an example, a select statement that retrieves and sorts selected columns and rows from the customer's table. So here you've got a select, and you're selecting two different columns, name and city. So these are your columns. From, this is all the name of your database, and in this case, it's customers. Where, okay, and this is where you have some criteria. In this case, you want to only bring back where the state is, WA, Washington, right? And you want to order that by name, right? And by default, it's going to be ordered in ascending value by default. You can also state ascending or descending, but by default, it's going to order by ascending value. So how to query a single table. The result of a select statement is a result table or result set. So that could return one result, or it could return multiple results, or no results at all, correct? So basically three different options there: 0 results, 1 result, or multiple results. A select clause lists the columns to be included in the result set. This list can include calculated columns that are calculated from other columns. The form clause names the table the data will be retrieved from. The where clause provides conditional that specifies which rows should be retrieved. To retrieve all rows from a table, omit the where clause. So if you don't have a where clause at all, it will retrieve all rows from the table. The order by clause lists the columns that the results are sorted by and indicates whether each column is sorted in ascending or descending order. To select all of the columns in a table, you can use the asterisk. So here it shows an example: select star from customers. All right. So in the real world, you want to be careful using that. Probably for most things we're doing here, we're going to be creating simple tables. But in a real world type scenario, you work in a company and stuff, that tables could have multiple multiple columns, right? And then also the result set you're bringing back, could be thousands of records. So so there's no reason to select. It's always easy and convenient for a programmer. Just let's select everything from the table, right? Even if you're not using it all, that's programmers tend to get caught up in doing that sometimes, and that's something that you need to be careful about. You really just want to select the data that you really need, so that your result set's much smaller, right? It's much more performant, right? Okay, this is a syntax of a select statement for joining two tables. So here, you're doing a select, and here's your column list from table. Here's your table 1, and then you can give it an alias here, right? You call it whatever you want here, and we'll discuss. We'll look at examples of this in the future, because this can kind of start getting a little more complicated. But you're going to select from your column list from your table. You give this an alias, and then you can join this with another table. There's different kinds of joins. In this case, it's an inner join. So you're going to do an inner join with table 2, and you give this an alias. And then on table 2 dot column, you do where this column equals this column. Okay. And we're going to take a look at this. I know this can be a little bit of confusing here, but it could be equals, less than, greater than. There's all your different options here, right? And then then the rest of this is just what we're already looking at, where you have your selection criteria, where, and then order by. Okay. So we're going to look at this example here is we've got a select statement that joins data from that invoice line items table and a products table. Let's see if they don't really have a good picture of that. Okay. But this is basically selecting your different columns here. Okay. From your line items table, then you're joining with a different product table. Okay. So if you kind of notice up here, you're bringing back this column from this table. You're bringing back the invoice ID from this table, another invoice line items. You're bringing back product code, but in this one, you're actually bringing back it from the different table. You're bringing back the description of the product, right? You have a product code in your invoice line items table, but you don't have a description. So to get the description, you need to go to your products table and get the description. Okay. So in this case, you're getting 4 different columns, right, from your invoice line items table, and you're getting 1 column from your products table, and that's why you're interjoining, right? And you're interjoining based on this product code. So you have a product code. You have the same product code in your invoice line items table, and you also have a product code in your products table. And by joining on this is how you can bring back something from a different table. Okay. And here's your where clause where item is 46. So yeah, this is just showing you're basically your result set. But obviously, like we said, your description here, your description here is only in the product table. Your invoice ID, your product code, right? Your unit price and your quantity. These are all within your invoice line items table, but your description isn't, as comes from product. This is just showing your result set. So this is what you're going to get back. Even though it's in different tables, your result set's going to be the returning what you wanted to get from all different tables. So that could be, maybe that's 5 different tables. Your result set will have different columns here, and them could be pulled in from different tables, right? But this is just your result set. This is just showing you an alias. Okay. So in this case, your name of your table was your invoice line items, and you gave it an alias of LI, right? So since you gave it an alias of LI, when you're getting the rows, you want to put your alias before your column name. So in this case, you're getting invoice ID from invoice items, because it's a possibility that some things could be in both tables, right? In this case, you want to make sure that you're getting the invoice ID from your line item, your invoice line item table. And then here, you're getting description just from your product code table. Because maybe it's possible in your line items table, you have a description that's for something else, not for the product, but you have a description and a different description with the same name, right? So, but in this case, we want to make sure we just get the product description. So we use the alias P that we gave it down here to get it just from the product table. Okay. So how to join data from 2 or more tables. A join lets you combine data from 2 or more tables into a single result set. Just like we looked at when we seen how the description was part of the result set, right? But that was only part of the product table and not the invoice line item table. The most common type of join is an inner join. This type of join returns rows from both tables only if their related columns match. There's other kinds of joins. We'll look at that a little bit more coming up here in the next couple of weeks. But we're not going to The inner join's the most popular one. Okay. You can make your SQL statements more readable by using aliases for table names. And that's always a good idea to have that so you know where that piece of data is actually coming from by using that alias. How to add a single row. So here's an insert statement. And like we were talking about, just kind of matching these up with the idea of CRUD, which we'll talk about more and you'll hear about more as we go forward. So for, create, CRUD is create, read, update, delete, and a create is going to be the same as insert. So the syntax of an insert statement is insert into, and you insert into a table name. All right. And then here's your column list, and here's your list of values. Okay. And here's showing you an example where you're inserting into the products table. And in this case, you're wanting to put data into the product code, the description field, the unit price, and the on-hand quantity field. And here you're listing your values. So the first one, the product code, is going to be this first one here. The second one is going to be your description. The third one is going to be your unit price. And the fourth one in values is going to be your on-hand quantity. Okay, here's an update. And that correlates, we're talking about the CRUD operations. That's update is update, right? And CRUD is also update. So you're updating a table name. And in an update, you do a set, right? Remember, insert, you're going to insert into. For an update, you have to use the set, right? And so you're using update a table, and you're setting a column equal to some value. In this case, it's, say an expression, right? So you're setting a column, one column to one expression, setting another column to another expression, etc., right? You can update just a single column in a table, or you may update multiple columns in a table. And then you're going to have a where clause here. And you're almost always going to have a where clause here because if you have multiple rows, you want to make sure, you're updating the correct ones. Sometimes you don't want to update all the rows. You want to make sure you update the selected ones, So a statement that updates the unit price column for a specified product. So here you update products. You're going to set the unit price equal to 54, where your product code equals MySQL. And this one here's a delete. And so here we're going to delete from the table name, from the table where selected criteria. So this could possibly remove one row, or it could remove multiple rows, all depending on your selection criteria. And so obviously that's one thing in the real world. When you do a delete, you want to make sure that you're very careful about what you're deleting, because once you delete it, you delete it. And actually in the real world, sometimes a lot of organizations will do is they'll have like I'll call it a flag or something, but they'll have a field that's like a Boolean, right? True or false. And so sometimes what they'll do is instead of actually deleting it, they make it invisible, right? They make it, they have like what's, kind of like a delete flag so that you can just mark that as deleted without actually truly deleting it. And then sometimes there might be some other process that comes back and could delete it at a later state, at a later point in time. Kind of a way to be a little more careful about deleting by just doing that. And so then how you would work on that, how that would work, is if you had that field where you had is deleted and you had that checked. Well, it's not really checked; it'd be a true or false. Is deleted true? And, in your columns, anything that got deleted would be true. So it'd still be in the database, okay? But then also, when you did your select statement, when you're going to get all the relevant data, you would select them only where that was true or where that's false, right? So that would bring back, it wouldn't bring back any deleted ones. It was just kind of an idea that, it's kind of used very much in enterprises where you just kind of set, we look at it as setting a flag. You're just setting a field to a value so that you can kind of still hold on to that data maybe while not returning that data. So from a perspective of retrieving that data doesn't exist, but in reality, it still exists in a database. Okay, so I think this is a pretty short chapter here, but there's still a lot we're going to need to go through the next couple of weeks, going through queries and so forth. I did want to go through. Kind of more of a review of just what we did here. So, well, basically, this is the study guide for the written test. But, I think it's just a good document just to go through. So, multi-user system components, key concept. Multi-user systems rely on several hardware components, typically clients, servers, and a network to manage connections and data flow. So here's an example. Imagine a company network where each employee's computer is a client and they connect to a server to access files and applications through the internal network. And like I said, there might be, depends on how, companies do things differently. And obviously with cloud computing, things are a lot different as well. And, we're not really going to talk about a lot of cloud type concepts. But, just wanted to kind of a, more of a traditional typical system. A lot of enterprises may have their database, their database server pretty much localized. It could be, you may be working for a company and on the campus of that company, they have servers and they have database servers that are used for internal purposes. And so you may be accessing data from those database servers internally, right? And so they wouldn't necessarily be accessed from outside of that campus. That campus could be called a local area network, right? It could be a small little campus and it's a local area network, and that only people can access that data is through using the network that's available to them in that little local area network. But then there's also a wide area network can be much greater than that. And so, it could be from a standpoint from a internet connection as well, where you're actually accessing a database server over the internet from a different location as well. Okay. Key concept: client server system divides tasks between client computers and a central server, allowing shared resources and efficient processing. So, in an online shopping platform, clients access product information from a central server which handles data storage and business logic, while the client's browser displays the user interface. In our case, our client is going to be our desktop application, right? Our C# WinForms standalone, right? So, okay, communicating. Applications communicate with database management systems using SQL queries to request data or perform actions. And let's just say here's an example. A mobile app might send an SQL query like select star from orders to retrieve order data from a database. Database management systems. The database management systems is critical for storing, managing, and querying data in a client server environment. Examples. So here, the examples they have is Microsoft SQL Server, which we'll be using. MySQL. MySQL is pretty much kind of an open source free one for the most part. You also have Oracle. So the ones that are used more in enterprise is Microsoft SQL Server, Oracle, DB2. There's others as well, but them are probably the top three from an enterprise perspective. Okay, these are all database management systems, relational databases. Okay, but there's also MySQL, and there's other ones that are free to be that can be used also. As well. Primary keys in relation to database. Key concept. A primary key uniquely identifies each row in a table. Always remember, a primary key uniquely identifies each row in a table, ensuring each entry is distinct. A customer ID column can serve as a primary key in a customer table, allowing each customer to be uniquely referenced. Foreign keys for table relationships. Key concept. Foreign keys link rows in one table to rows in another table, creating relationships between data. Here's an example. An orders table might have a customer ID foreign key that references the customer ID primary key in the customer table, linking each order to the respective customer. One-to-many relationships. This is when a row in one table relates to multiple rows in another. It is a one-to-many relationship. A single customer can place multiple orders, meaning each customer ID in the orders table could appear multiple times for different orders. So your orders table is going to have multiple customer ID, could have the same customer ID, right? It's not always going to be you because a customer could have multiple orders, right? So that way you can get information from both the customer table and from the order table based on, using that customer ID that's also in the orders table, right? So it's kind of like if you're ordering something, let's say via Amazon, you can actually look at your orders. So if you have multiple orders, it's based on your profile, right? It's based on your customer login ID, and based on that customer ID, and that's basically what Amazon's doing under the hood, is based on your customer ID that's associated to you, right? It's bringing back your multiple orders from their order table, right? Here's a result set from a select statement. The result set is a collection of data rows retrieved by a select statement. So it's just showing you executing select product name from products where category equals electronics might return a list of product names within a electronics category. So this is showing possible, you're going to be returning many. So always remember, a select statement could return no results, could return one result, or could return many results. Select statement limitations. A select statement retrieves data but cannot alter it. Yep, the select statements is for reading only. We were talking about the CRUD, right? And so that is the read. Create, read, update, delete. Select is a read. A statement like select star from customers retrieves customer data without making changes, while an update statement would be used to modify data. Okay, we talked about inner join. An inner join returns only rows where related fields in two tables match. Right? Select statement filtering. So this is basically adding your conditional statement. So that's your where clause. And then, so you would go ahead and select star from employees where salary is greater than $50,000. So that's going to return multiple, one or many, zero, one or many, if salary is greater than 50,000. And like we already stated, just to kind of reiterate, it's always best practices to only select the columns you really want. Obviously, if you got a very small set of data, you can do select star, but if not using it, you really don't need to return it. So you can just state the exact columns you want to return as opposed to using the star. Just one thing, I've worked on projects before where, there's kind of a side project. We actually had to go in and work and fix, and because we were selecting too much data all the time, and we actually did like a refactoring to go in there and actually grab only the IDs we had, because we had some old code where everybody was just using select star. So it's always best just to select the specific columns you really need. Result set structure. The join clause combines tables with the order by clause. And then in this case, it's doing an order by last name in descending order, right? So you can do ascending or descending by default. By default, it's ascending. So if you don't see an ascending in there, it's going to be by default ascending. If you want it descending, you have to state that it's in descending order. Insert statement. That's the same as a create statement in our CRUD concepts, right? Create and insert's the same. You're inserting into, you're adding a new row to a table, right? You're adding a new record, right? It's all about adding records. So in here, you make sure whenever you do an insert, you're always going to be using the into, the name of the table, and in this case, you're adding a product name and a price, and then your values. And always remember that they're going to correlate. The first one's going to correlate to the first one in your list, which is product name here, and the second one is going to correlate to the second one in the list, which is price. An update statement. The key concept modifies data in an existing row. So here you're updating employees and you're setting title equals to manager, where the employee ID is 5. So always remember with an update, you always need to use the set keyword as well. Update and set. And as best practices, also make sure you want to make sure because you can get away with not necessarily doing it, but when you're using the different commands, right? Make it all uppercase, right? Delete. From is another keyword. These are all the SQL specific things, right? The SQL specific syntax. Make them all uppercase. Here you got delete, from, where, right? These are, user created. You created a table called orders. Your order date's a column, right? You created that yourself, right? Here you're using camel case, right? Here you're using camel case, but always make these all uppercase. So especially so it stands out too. So you can always see that set for an update. Into is required for product, an insert, right? Values, right? All right. So going forward here. So tomorrow what we're going to go ahead and do is I'm going to go through the assignments. I don't know if there's really much to go through. The hands-on test is pretty straightforward. We have a written test. But we are going to be really getting into this final project, and this final project It's going to be 1,500 points. I'm not going to go through a lot of it right now, but it's it's 1,500 points. So it's going to be over multiple weeks here. There's going to be multiple steps on that, but I'm going to go through that tomorrow. And then, but also as far as from a database perspective, we're going to go through some more database fundamentals, look at some retrieving some data from a database, updating, deleting, all of those, and I'll show you how to set up a database. Okay, so that's all I have for today.